You ever wonder if a factory could tell you it's feeling a little under the weather? Before a catastrophic breakdown? Well, it turns out we're in the middle of a revolution where machines are doing exactly that. So let's dive into the world of intelligent manufacturing, where we're basically giving entire factories their own high-tech fitness trackers. Here's what we're going to cover. We'll start with how things used to be, the old way of doing things. Then we'll get into what exactly makes a factory smart. We'll take a peek under the hood at the tech, look at the absolutely mind-blowing results, and finally, we'll get real about the challenges that still exist on the factory floor.
All right, so to really get where we're going, we've got to understand where we came from. We're talking about a massive fundamental shift in how we keep tabs on our production lines.
For decades, factories ran on a pretty simple model. You'd do some spot checks every now and then, maybe take a few samples by hand, and then you'd wait for something to break. When it did, you'd fix it. It was completely reactive. But now we're shifting to an intelligent model. This means continuous 24/7 monitoring where all the data is collected automatically, which lets us take predictive action before anything has a chance to go wrong.
So this whole new approach, this intelligent way of doing things, is all built around one central concept. So let's get a really clear definition of what we're actually talking about here.
The official term for it is process monitoring. And as our source material lays it out, it's the continuous measurement and interpretation of sensor signals to check the health of, well, basically everything. The machines, the products, the whole shebang. But what does that really mean?
This analogy just nails it. The old way? That was like going to the doctor once a year for a checkup. You get one snapshot on one day and hope for the best. Intelligent monitoring, though, is like wearing a fitness tracker that's watching your heart rate, your sleep, your steps, all day, every day. It gives you this constant, super rich stream of data, letting you spot the tiny little issues long before they become big health problems.
So, how in the world do you actually strap a fitness tracker onto a giant industrial press or a sprawling assembly line? Let's pull back the curtain and look at the tech that makes all of this possible.
It's really a stack of technologies working together. It all starts at the bottom with sensors. They're the eyes and ears, measuring everything from tiny vibrations and temperature changes to what a camera sees. All that data gets collected and shot across these incredibly fast, synchronized networks to the brains of the operation, which are these powerful analytics platforms and AI that can live right there on the machine or way up in the cloud.
So it all boils down to this simple but incredibly powerful loop. First, you sense what's happening with that network of sensors. Second, you process that absolute flood of data with AI looking for patterns a human could never spot. And finally, the system can act on what it finds, either by pinging an operator with an alert or, in some cases, by making tiny automatic adjustments all on its own. Sense, process, act. That's the core of it.
Now this is where things get really cool, the AI brain. You see these acronyms like LSTM and GANs, and they sound complicated. But what they do is pretty straightforward. They're just ridiculously good at spotting subtle patterns that signal a problem is coming. And here's the wild part. What if you don't have enough data of a machine failing to train the AI? Well, some of these AIs can actually create fake but totally realistic data of failures to train themselves. It's kind of like a pilot training for thousands of hours in a flight simulator before ever stepping into a real cockpit.
Okay, this technology is fascinating for sure. But what does it actually do? What's the bottom line? Let's talk about the real-world payoff, because the results are, well, they're pretty spectacular.
I mean, just look at this. A field study in textile manufacturing put this stuff to the test, and the numbers are staggering. We're talking fewer defects, more products made right the first time, and way less time with machines just sitting idle. Let's break these down one by one.
First off, a 32% reduction in product defects. That is huge. By catching those tiny little deviations in the process as they happen, the system literally stops mistakes before they start. That means higher quality right off the line.
Next, a 28% jump in what's called first pass yield. That's just a fancy way of saying the product was made perfectly the first time, with no need for fixes or do-overs. For efficiency, that is a massive win.
And finally, a 25% drop in operational downtime. This right here is that predictive power in action. Instead of a machine breaking down unexpectedly and stopping everything, the system says, hey, this part needs attention, so you can schedule maintenance. The whole line just keeps flowing. And think about the ripple effects: less waste, more sustainable manufacturing, and a whole new level of reliability.
And this isn't just a one-off thing.
Other studies using digital twins, which are basically ultra-realistic virtual copies of a factory, have seen similar results, with some reporting almost a 23% increase in the total amount of stuff they can produce. The evidence is pretty overwhelming. This works.
Okay, but let's be real. Installing a brand new central nervous system into a complex factory, it's not exactly plug and play. There are definitely some real-world hurdles that engineers have to clear. But what's so cool here is that for every major challenge, there's some really clever solutions being developed. For instance, network lag. If sending data to the cloud and back is too slow, no problem. You use edge computing to process it right there on the factory floor for millisecond decisions. Don't have enough data of a machine breaking? We already saw how GANs can just create it. The point is, these aren't roadblocks. They're just the next set of engineering puzzles to be solved.
So think about it. We've given our factories a fitness tracker. We've given them a nervous system. We've given them a voice. They can now tell us in real time exactly how they're doing. This is already changing how we make everything. And that leaves us with one last, pretty fascinating question to chew on. Now that every single machine has a voice, what new and unexpected things are they going to tell us next?